Hello all, my name is Shantanu Suryavanshi and today I am going to present a topic Deep Q Learning using Tetris game. So basically, what is a Tetris game? As you know, we may have played that Tetris game on a console or at least on a cell phone. So basically, Tetris is a game that involves placing pieces on top of each other, which has the seven arrangement so that in those seven arrangement, if we fill them in one over other and if we fill a rectangular grid, then we'll get a point. So a common human approach to this problem involves looking for open spaces and changing the shape of the piece so that it might match the current piece. So this project deals with the playing of Tetris game using deep Q learning algorithm. Let's get a demo of this project. In order to run this project, the command is just python space run.py. This project is based on machine learning. Uh, the model is built using Keras by TensorFlow as a backend. So here we go. This was the first round. The output screen, which is the playable of the video, gets displayed every 50 episodes. This percentage is the TQDM model in which we show the progress bar. As we see that the our agent is not scoring much because it's just the initial state and it is learning from it. Once our agent reaches more than 1200 to 1400 episodes, it will learn the most thing about this game and it will score a good points in that. Now we can see that after the training of 927 episodes, the agent is trying to learn. We can infer this by the score is increased from 12 to 42. So this means that our agent is learning from its own using the deep Q learning algorithm. Here we go. Now the score rises to 112. As the episode increases, the complexity of the program also increases. That's why it takes more time for the single iteration as we go on to the 1000 episodes. As we are reaching the 1400 episodes gap, we'll see a significant difference between the starting and the ending score. So here we go. Here we can note that the score is 96 and the first score whichever our model score was 12. So from this we can infer that our model is learning from deep Q learning algorithm. Scope. A project dives into the scope of machine learning. So obviously there are tools and techniques which are involved in machine learning in order to implement this project. So some of the tools and techniques are the TensorFlow. A TensorFlow is a Google's deep learning framework which we will use a backend in order to train our deep neural networks. A Keras. A Keras is a deep learning framework for training neural network. This Keras we will use this Keras framework in order to train a model and evaluate our training. The third one is the OpenCV Python. OpenCV Python can be used to display our Tetris game because the main use case of the OpenCV Python is to build a Python GUI. The TQDM. as we have seen the progress bar. uh, it ranges from 0 to 100%. This can be shown using the TQDM. The next one is the CUDA. I have used the CUDA framework. That's nothing but the NVIDIA's GPU machine learning uh, machine learning training framework, which can be used to train our machine learning model faster. The next one is the Sublime. That's the text editor in order to edit the code approach. Uh, a machine learning model is an unsupervised learning model, is based on an unsupervised learning model. So basically, what is an unsupervised learning? Unsupervised learning is a type of machine learning that looks for previously undetected patterns in the dataset with no pre-existing labels and with a minimum human intervention. That means in the unsupervised learning models, we are not given the uh, labels, that means the outputs. So our models cannot compare with the output labels, so it would try to evaluate on its own. So therefore we have used unsupervised learning. Here I have used reinforcement learning with deep q learning for implementing the Tetris game. The methodology, uh, the the neural network which I have used is the reinforcement learning. In reinforcement learning, the training of the machine learning model uh, takes in a sequence of decision. The agent learns to achieve a goal in an uncertain, potentially complex environment. It only contains a agent and an environment. The agent gives a state to the environment gives a state to the agent. Then the agent performs an action on that state. Then an environment evaluates it and gives a reward or a penalty to the agent, so that from the reward it would know that the given action was correct, and from the penalty it would come to know that it was a wrong action. So this is used to maximize the goal, and in order to learn from this set of actions. So basically, what is a Q learning? Q learning. Q learning is a model-free reinforcement learning algorithm to learn a policy telling an agent what action to take under what circumstances. It does not require a model of the environment, and it can handle problems with stochastic transitions and rewards without requiring adaptations. Basically, Q-learning stores data in the table form. As we can see, it contains state actions and the values, which are then converted into the Q values. Uh, Q values, which can be further used for a training process. The Q-learning algorithm is demonstrated as first of all, we'll initialize the Q table by the set of random values. Then we will choose an action. After we'll perform that action, then we'll measure its reward or a penalty. Then we'll update it again in the Q table. So based on the frequent, that's the recent uh, actions, we will come to know that which actions were good and which were the bad. So according to that, we'll perform that set of actions. uh, Q learning implementation. In our model, uh, I have implemented a deep Q learning agent. For that, I have first created a class named as DQN agent. Then I have given a build model function which builds the model using the Keras deep learning framework. Then after that, we train the model, and then we predict the values in order to display it into the Tetris game. So let's get into the code. Our project contains three files. One is the run.py, second one is the logs.py, third one is the dqn agent.py, and the fourth one, which is the environment, is the tetris.py. So first of all, run.py contains our main method. Here we have imported all our required things, uh, in which one is the Tetris, that's our environment, second is the logs, and third one is the DQN agent. So first of all, we initialize all the variables by giving them the values. So here we have kept the number of episodes as 2000. We have set up the env variable to the Tetris method so that we can get the Tetris environment just by the env variable. After that, we have set up our epoch as 1, a batch size as 592, a discount factor as 0.95. And then we have created a variable agent in which we have initialized a DQ and agent by giving the parameters whichever are the above, such as the number of neurons, activations, epsilon stop episode value, memory size, discount, replay start size. After that, we have given the path for the log in order to store the logs. After that, this function is used to display the progress bar, that is the 0 to 100% progress bar, using the DQDM framework, so that we will know the progress of our project, the learning process. After this code is used to render the screen. After every 50 episodes it will render the screen. Then this one is the game part. Okay, this part gets the base state, the next state, and applies this base and next state to the environment so that it can render it, and also it uh, stores it into the memory. After that, if we want to train a model, so we do agent.train the space batch size and the number of epoch, where batch size is 512 and the epoch are 1. This code is used to store our log, and then after that a main method which is the dqn method. The second file is the tetris.py. Here, as we have seen that we have taken the tetris in the environment variable, so our tetris file contents is nothing but an environment. So it contains a matrix of colors, then the reset function, which is used to reset the game to the correct state, then a rotate piece function in order to rotate the pieces, get complete board in order to return the complete board, uh, get game score in order to get the game score, uh, new round in order to generate a new round, check collision, it checks whether the collision between two pieces is there or not, the rotate in order to rotate, then add piece to the board, places piece in the board, returning the result board, then the clear lines in order to clear the lines, because if we complete a block of code then it get diminishes, so this is cleared using the clear function. Then the bumpiness, it's the sum of the difference of height between pairs and the columns, then the height is the sum and the maximum height of the board. Then next one is the get board properties in order to get the properties of the board. These are all the functions related to the Tetris environment. The next one is the get state size. Then the next one is the play function, in which we give rotation, rendering, and the render delay parameters. Then after that, the render function. In this render function, as we know that after every 50 episodes we will render the output, so this is done by using this function. So the next part is, after Tetris we have a DQN agent. The DQN agent is nothing but an deep neural network. We have implemented the deep Q neural network algorithm in this file. So first of all, uh, we'll import keras dot models from the we'll import the sequential model from the keras framework. After that, we'll import the dense model from the keras dot layers. After that, we'll import numpy and the random variables. Here we have initialized state size, which is nothing but the size of the input domain, memory size, which is the size of the replay buffer, discount, it is how important is the future rewards compared to the immediate ones, the epsilon, it is the exploration value at the start, epsilon minimum is the minimum value of epsilon stop episode is the at what episode the agent stop decreasing the exploration variable, uh, neurons is the number of neurons, activation is the function which we want to use as an activation function, then the optimizer, what optimizer we want to use, replay start size, the minimum size needed to train the model. Then after that, this function def build model is used to build a model. It is nothing but an sequential model, sequential Keras model using the dense layer by providing the number of neurons, number of input dimensions, and the activation function. Here the activation function which we have used is the ReLU function. Then after that, the add to memory function is used. As we know that the deep Q network stores all the values in a list form. So add to memory function is used so that it will append the current state, next state, reward function in this. Then the random function, for the stat state, we don't have any single values, so in order to generate those values we'll use the random values. Then after that, predict values will predict the values from our model, our trained model. Then the act function, which returns the expected score of a certain state. The best state function, which returns the best state from the given collection of set. Then after that, the train function. In this train function, we'll train a model using the deep Q network, in which we'll give the batch size. By default, we have taken batch size as 32 and epoch as 3, but we have passed the epoch value as 1 and the batch size as 5 and 2. After that, we have the logs.py. In order to store the logs, in order to get the output, we'll use the custom TensorBoard framework. So we have imported TensorBoard.summary import uh, file writer, and from TensorFlow.keras.callbacks import TensorBoard. Here we have defined a class named as custom TensorBoard with an argument as TensorBoard. Well, we'll use a file writer in order to store the file as in logs. So this is nothing but the overview of our code. Next is the evaluation criteria. In order to evaluate a project, we'll need an evaluation criteria. So the evaluation criteria is as follow. Each block placed yields 1 point. So if we place any single block, then we'll get a point. Then if we create a brick of the block, means the whole block gets completed, then it will get cleared off. So we'll also get the number of lines cleared raised to 2 into the board width number of score. If we lose a game, it will subtract a 1 point. An arrangement is valid only if the brick aligns with the least one another brick along its full side. So this is the criteria for our evaluation. The next one is the outcome. From this graph, it can be inferred that after 100 and 1400 training episodes, we get the highest result. That is, we score the highest amount of result after training about 1400 episodes. So from graph, we can see that at 200 episodes, the score was very little. Means till the score of episodes 1000, it was very little. Then it started bumping up at this episodes 1200, and after 1400 we got the highest score. So this is what we can infer, that the deep Q learning network learns from itself and gives us the highest expected output. So future scope. Deep Q learning can be used in various sectors wherever reinforcement learning is applicable. So some of the future scope are the healthcare. In order to do any set of surgery or something, it can be used in the healthcare or in the medical sector. Next one is the robotics. Robotics, in order to train the robots, which can be used for the military applications or for any household application. If they can learn from the set of actions by repeating itself, then those are also applicable for the robotics. Then in order to automate the financial process, such as the stock prediction and other things, it can be also used in finance. The gaming, the one which we use in this project, is nothing but the gaming, which can be used to play against the humans, so that we'll get the natural feel of playing the game. Next one is the NLP. NLP is the natural language processing. So we can use it in a way for example a Google Translate comes. Conclusion. From this assignment, I have learned implementation of Q-learning algorithm on Tetris game, implementation of neural network and interfacing with graphics through Python programming. Any questions? Thank you.